All right, so this is a continuation of our lesson on solving compound inequalities with the word or the word and. Let's look at number one to get started with this. We have negative 3x is greater than or equal to 12, and, so notice the word and, 2x minus 1 is less than 3. All right, so in solving a compound inequality, you're going to solve each inequality individually first. And then you're going to look at the word that combines those two statements. So let's look at each one first. So let me go ahead and rewrite this one over. So I get 3x is greater than or equal to 12. Now remember, to get x by itself, I've got to divide by the coefficient of x. So in this case, it's a negative 3. Now remember, though, dividing both sides by negative numbers. So remember, when you divide or multiply both sides of an inequality by a negative number, you've got to reverse this inequality statement. This inequality statement is no longer true. So when I do that, negative 3 divided by 3 is 1. 1 times x is x. So the greater than equal to becomes less than or equal to, and then 12 divided by negative 3 is a negative 4. All right, so any real number less than or equal to negative 4 satisfies this statement right here. And you can see that's true. So if you pick a number that's less than or equal to negative 4, let's say negative 5, right? So negative 3 times negative 5 is 15, and positive 15, and 15 is greater than or equal to 12. All right, so any real number less than or equal to negative 4 satisfies this. Now let's go ahead and solve for this one. So I'm going to add 1 to both sides. When I combine like terms, I get 2x is less than 4, dividing both sides by 2, and then reducing, I get x is less than 4 divided by 2 is 2. All right, so any real number less than 2 is the solution to this. But remember, I'm trying to find the solutions to this compound inequality. What values of x will make this statement true and this statement true at the same time? So when we talk about that's the intersection of those two graphs, those two solutions. So let's graph each one individually. All right, so that's the way you would do this. You would look at each one individually. So here's negative 4 right here. And so let's go ahead and graph this. So x is less than or equal to negative 4. There's a closed circle because of the equal sign. That means that's a solution. Negative 4 is a solution. And there's the graph of this one. Over here, let's put this underneath and make sure it's in the right order. So 2 is to the right of 4. And this is less than. So there's an open circle going to the left. All right, now remember, you're trying to find which of those solutions here, which of those solutions make this compound inequality a true statement. Now remember, that's an and statement. So those solutions has to satisfy both at the same time. So hence the word intersection. So just look and see where they overlap. Kind of do something like this. Shade it in like that. So this is where they overlap, right? That's it. From negative infinity to negative 4. So your solution, so you're going to put all this on one graph. So your graph has to be one number line. So here's negative 4. That's all you need is negative 4. Closed circle, and then going to the left. So remember, what you found is that your solution, your graph will be from negative infinity to negative 4. So that's this right here. So any real number that's shaded is a solution to both of those. Nothing else will work. And then in interval notation, so if you want to do this in interval notation, so that's your graph of the solution, and then this would be the interval notation. So you go from left to right. So you say from negative infinity to negative 4 with a bracket because of the closed circle. So negative infinity to negative 4 with a bracket. Okay? All right, so that's number 1. Let's look at number 2. So number 2, I have 2x minus 3 is greater than 9, and x plus 5 is less than or equal to 1. So remember an and statement, so that's the intersection. So if you're looking for the intersection of those two graphs, you got to find the solution to each one individually. So you're trying to find what real numbers for x will make these two inequalities true at the same time, since that's an and statement. So let's go ahead and solve each one individually. So I'm going to go ahead and add 3 to both sides. So 2x, this is 0, is greater than 12. Divide both sides by 2 to get x by itself. Since I'm multiplying x by 2, the opposite is divide by 2. 2 divided by 2 is 1. 1 times x is greater than 6. So any real number greater than 6 is the solution to this one. All right, now let's find a solution to this one. So I'm going to subtract 5 from both sides. And when I do that, this is 0. I get x is less than or equal to 1, and negative 5 is a negative 4. So any real number less than negative 4 is a solution to this one. Okay? But remember, that's an and statement, right? So let's graph each one individually. So I'm trying to find what solutions to both of those will make this statement true at the same time. So graph each one individually. So here's 6. We're doing this one first. Open circle going to the right. All right, let's do the next one. Here is negative 4, right? Negative 4. Closed circle, since there's an equal sign, going to the left. All right, now remember, I'm trying to find which of those solutions here that's shaded, will be a solution to this compound statement that has the and statement, so the intersection. So where do those two graphs overlap? Well, if you notice, they don't overlap at all, right? So there's no overlap. There's no intersection. No intersection. And so therefore your solution, just what you're going to say. Your solution, you're going to say no solution, or you're going to say the empty set. Okay, something like that. Now, usually though, a graph will be listed here, right? So leave it blank. Leave the graph blank. So there's no shading. No shading. All right, so there's your solution. So it's just the empty set, no solution. Okay, no real number. There's no real number that will make both of those true at the same time. Because what makes this statement true is any real number greater than 6, and what makes this statement true is any real number less than or equal to negative 4, but they have nothing in common. All right, so no solution, number 2. All right, let's do number 3. So number 3, let's do another and statement. So number 3, we have 3x plus 1 is greater than 22, and 2x plus 3 is greater than or equal to 11. All right, so remember the and statement says the intersection. The intersection. All right, we're going to solve each one individually. So let's go ahead and subtract 1 from both sides here. So I get 3x is greater than 22 minus 1 is 21. This is 0. Divide both sides by 3 to get x by itself. 3 divided by 3 is 1. 1 times x is x. So I get x is greater than 7. Over here, let's go ahead and solve for x here. Let's find the solution to this inequality. Subtract 3 from both sides, and I get 2x is greater than or equal to 8. Divide both sides by 2, and then reducing, 2 divided by 2 is 1. 1 times x is greater than or equal to 4. So any real number greater than or equal to 4 is a solution to this statement. All right, but I'm trying to find the solution to the compound inequality. Which of those right here makes both of those true at the same time? Hence the intersection. So what we're going to do first is we're going to graph each one individually, and then we're going to compare the shading. We'll compare what's being shaded. So here's 7, no equal sign, so I'll be an open circle, since 7 is not a solution because there's no equal sign, going to the right. Here's 4, put 4 in the proper place though, 4 is to the left, right? And then greater than or equal to, so closed circle, since there's an equal sign, 4 is a solution, going to the right. Okay, now I'm trying to find which of those solutions that are shaded here is a solution to the compound statement with the word and. So that's the intersection. So where do those two graphs intersect? Where do they overlap? So there is some overlap. That's here. So your solution, you're going to put that on one number line now. So you're going to go from 7 with an open circle going to the right. So there's your graph. So any real number greater than 7 is a solution. So in interval notation, you're going to say parentheses 7 to infinity. Okay? So your solution would be any real number greater than 7, right? So any real number greater than 7. So this is your graph. This is interval notation. And this is inequality notation. Okay? All right, so that was number 3. Let's look at number 4. Number 4 is going to be an OR statement this time. So let's do an OR statement. So remember, OR means union. So number 4, we have 5x minus 1 is less than 24, or 2x minus 3 is less than equal to 1. All right, so remember, that's an OR statement. So OR statement means union. So remember, when solving a compound inequality with the word OR, you're just looking to see which solutions satisfy either one of those, either this one or that one. And so it's anything that's shaded. Remember, union is anything that's shaded in both of those. So let's solve each one individually. So I'm going to add 1 to both sides. So I get 5x is less than 25. The coefficient of x is 5. So I'm multiplying x by 5. The opposite of multiplication is division. So I'm going to divide both sides by 5 and then reducing. 5 divided by 5 is 1. 1 times x is less than 5. 25 divided by 5 is 5. So any real number less than 5 is the solution to this one. Now let's solve for this one. So we're going to add 3 to both sides. So I get 2x is less than equal to 4. Divide both sides by 2. I get x is less than equal to 4 divided by 2 is 2. So any real number less than equal to 2 is the solution to this. But remember, I'm trying to find the solution to the compound inequality. So any real number that's shaded is going to be a solution to the compound inequality because it's just got to satisfy one of those. And so basically, if you look at that on individual number lines, here's what we have. So x is less than 5, open circle, since there's no equal sign, going to the left. And then here, x is less than 2, put 2 in the right place now, so 2 to the left of 5. Closed circle, going to the left as well. And remember, that's an OR statement, right? So an OR statement is anything that's shaded. So anything that's shaded. So I want you to notice that everything that's shaded is from negative infinity all the way to 5. So everything that is shaded, all of this that is shaded, anything shaded. So your solution in one number line, don't take intersection now. The intersection is only for an AND statement. This is an OR. So anything that's shaded is a solution. So in one number line, you're going to say from negative infinity, you're going to shade in all that, negative infinity up to 5 with a open circle. All right, so there's your solution. In terms of interval notation, you're going to say negative infinity with parentheses, 5 with parentheses because of the open circle. So that's interval notation, right? Now they ask you to put this as an inequality. That's easy. So this means any real number less than 5. So x is less than 5. X is less than 5. So that's the inequality notation. And then this will be the graph. All right, so that's number 4. Okay, let's look at one more, number 5. Let's do an OR statement. So number 5. And number 5, we have 4x minus 1 is greater than or equal to 27, or 2x plus 1 is greater than negative 7. All right, we're going to solve each one individually, but notice that's an OR statement, so it'll be the union. So whatever is shaded will be the solution to both of those, to this compound inequality, because it satisfies at least one, either this one or this one, because that's the OR statement. So if we solve each one individually, here I get 4x. I'm going to add 1 to both sides. I get 4x is greater than or equal to 28. Divide both sides by 4. And reducing, I get x is greater than or equal to 7. So any real number greater than or equal to 7 is the solution to this first one. Let's find the solution to the second one. So I'll subtract 1 from both sides here. And when I do that, combine like terms, this is 0. I get 2x is greater than a negative 7 and a negative 1 is a negative 8. Divide both sides by 2, and reducing, I get x is greater than negative 8 divided by 2 is a negative 4. All right, so any real number greater than negative 4 is the solution to this one. Remember, that's an OR statement. So the solution to this compound inequality would be the solutions that both of those have. All right, so meaning anything that's shaded. So the way I would do this is is I would look at each one individually. So here's 7. Greater than or equal to is a closed circle since there's an equal sign going to the right. Here's -4 right here, open circle going to the right. Okay, and remember that's an or statement. So anything that's shaded is a solution. So you're going to go from -4 to infinity. So your solution on one number line. Now don't think intersection here. Okay, so that's an or statement. So anything shaded is a solution. All right, so you're going from -4 open circle going to the right. So notice this part is here and this part is this. So this part's already in here, right? Okay, so that's what the graph should look like, going from -4 to infinity. So interval notation, -4 to infinity. If you want to put this as an interval notation here, so if you want to put this as an inequality, you're going to say any real number greater than -4. So x is greater than -4. So that's your inequality statement. And this would be your graph. All right, so that is some examples on solving compound inequalities with the word and or the word or.